Well, again, it's if you just hopped on here in the last few minutes and listened to Kevin and I, my name's Aaron Allsbrook. It's a pleasure to be here. We're going to talk about a topic that has been a topic for at least I don't know 14 years. How long ClearBlade's been had this product in the environment, what we've been doing in IoT, but security has been important for all of those years. We've seen when people lean into security and do it well. We certainly have seen others not do security well, and we hear some real horror stories. So today we're going to kind of go through security. There's a little running joke in ClearBlade about what is security. Well, it's like a bear. You don't want to mess with it, and you always need to be running, getting better at it. So we're going to go through that today. I'll dive in just a little bit to talk about who ClearBlade is, and then we'll learn a little bit about the different way this all comes together. We will open the session up for questions at the end. I do appreciate the chance to talk about it. I'm not sure I always have all the answers, but I love to keep getting questions to keep expanding the knowledge. And obviously, there's much more in this space to continue to do. And then I do hope I get to see folks in Harrisburg, and we can continue this conversation at the next IoT Live Slam. With that, let's dive in. Don't poke the bear, security and IoT. Just as background, why am I talking about this topic? And what is my background specifically in the overall understanding of this? Well, ClearBlade is software. We're software for IoT and Edge. We implement the AI into the IoT lifecycle, and then ultimately we do drive the creation of digital twins, connected digital twins specifically. That's an important part of a digital twin. If it's just not connected, it may as well just be a model and code somewhere. So a connected digital twin is where ClearBlade focuses. And it's across a number of industries. ClearBlade software is working the transportation, the utilities and energy space, building and facilities, manufacturing. When you look at all those things together, you should sort of feel a heavy industrial and IIoT kind of focus. That is where we do lean in as a company, trying to solve those industrial problems. Those problems tend to have heavy teeth in terms of the complexity, lots of brownfield, greenfield work going on, but we do it across the world. We do it for lots of different use cases, lots of different ways, and challenges show up with security. When it's all said and done, there's about 6 million plus connected devices going on in this overall ecosystem on ClearBlade software. Some devices are gigantic, big, expensive things. Some devices are lighter weight, small sensors and fields. So a lot of variety in what's going on in IoT. But this is what ClearBlade's solving, and this is why I think so much about what is security, because all of these solutions are so important. All of these solutions have specific needs and levels of impact and risks and stuff associated with them. My background in the space, I begin life trying to be in more on the hardware side. In university, I studied computer and electrical engineering. So I was all about getting into that thing, that chip, that board, that sensor. That was my training and education, so to speak, to begin with. And then I immediately moved into the software world and thought I'll probably be done with that hardware stuff forever. And I built and consulted on middleware, building large applications for enterprises, for doing transactional trading, for doing financial regulations, for doing connected billing order and supply, all kinds of major enterprise applications, moving data around and serving up and helping enterprises run their business. I then moved to ClearBlade as a co-founder and was the chief architect of both our IoT platform and our IoT Edge product. So the good news is all of that hardware expertise suddenly became relevant again as we tied those two worlds very, very tightly together. And it is why I have so much fun in this space, is because I'm constantly reaching to different parts and different experiences and trying to tie these things together. Overall today, where do I build my security and understanding? Well, I do lead the security for compliance and things like our SOC 2 or ISO 27001. These are things that I'm heavily involved in, constantly learning, constantly trying to do a better job of it with each revision. There's certainly other frameworks out there from other groups, NIST and others that I'm familiar with, but ultimately, I spend a tremendous amount of time trying to make sure the posture of ClearBlade, the posture of our company, the posture of our solutions are meeting these best of breed requirements and practices and standards. That's a little bit about me. That's where I'm coming from when I look at these problems. I'm trying to make sure that we can not just be compliant, but truly, truly secure. We always are, it's a moving bar, so to speak, of we are always trying to get better, trying to introduce new best practices, learn from others, and see what we can do. So with that, let's dive in and kind of get into the meat of the content here today. I'm not going to necessarily dive in and show you a specific architecture, so to speak, of a specific solution and kind of tear it apart. I think that in some ways might be a negative impact to somebody's specific security model. But instead, I'm going to go through what I typically see and where I typically try to understand what are the risks associated with an IoT architecture, an IIoT or an OT architecture, and then how do we begin to resolve those and where do certain categories of products fit into those overall solutions. I'll go all the way from a very simple IoT solution to kind of an industrial solution, a brownfield solution made IoT enabled, and then even talk about some of the cloud security concerns and why these clouds have some great elements of them or components of them that we do want to leverage, and why there may be some security value in even moving to cloud for certain pieces. I will go through some example solutions that are doing things like this that kind of speak to the element of what's important at the end, just to kind of tie some reality to it all. But that's our agenda today. So hopefully we have a little fun. We will open up for questions at the end. I believe Kevin will help me kind of translate all those. I'm trying to watch all the screens, but we will open up for questions at the end if there is anything specific people have come to the conversation with today. So let's talk about a very simple IoT solution. IoT is a device on the left-hand side, and most often we're buying some cool new thing, something for the home, something for work. It's called an IoT device. It's connected, it's smart, it's intelligent, whatever we've called this little product that we've got, and it shows up on our mobile phone. It shows up on our computer screen on the far right. Somewhere in this architecture, that device in a common architecture is communicating over a protocol called MQTT. Not really the requirement. There are other ways it could do it, but that data streams off that device and it hits what we call a broker. A broker is this piece of software, middleware, I believe is the term that best describes it, that sits in the middle. It basically receives the data and potentially sends data back to the device, and then it says, okay, database, here's the data, let's store it. Okay, application, mobile phone application on the server side, here's the data that we just got from the device. You can now send it to the mobile phone and let people see that the temperature has changed. Let people see that the garage door is open. Let people see that the barbecue thermometer is now cooking the meat. Whatever that is. It is a very simple architecture in this diagram of broker, database, and maybe a little application, Node.js, whatever you might have written that in. That's what's going on in many different cases. Now, when you look at this, you say, well, where is the security problem here? I like my device. I like my user. Well, ultimately, it comes down to there are untrusted segments of this architecture and there are trusted segments. And really, it's easily said. The part that we own as the software manufacturer, software creators, is that little trusted area. We know what's going on those servers. Even if we make the device, we are putting that device into the wild. It's going out into the field, potentially going over public cellular network, public Wi-Fi, however it's going, Internet of Things, it's on the internet. It's maybe under someone else's control. All those devices in our house aren't locked behind lock and key. They have owners associated with them who can get in them and do whatever they want. So that left-hand side is untrusted. It's not too unlike that right-hand side, the mobile phone, the computer. These end users also are, so to speak, untrusted using our systems. So we really have to look at this and say, how do we work with our trusted piece we own, and then these two untrusted ends, whether they're through these static connections or API calls, how do we bring trust back into this conversation and into this architecture? We see risk. Why is there risk on this left-hand side? Well, very often, even if we design the hardware or, in our own labs or whatever, we're going to take that and manufacture it at scale somewhere else. That manufacturer is a third party. And while we may have all of our processes to secure it best as possible, it's not us. We know that whatever that software is put on it, right, that comes in at a low level firmware level. And so there's a certain level of that hardware as it moves through the supply chain. There's some trust to check on. We know that once that device is installed, what is the physical security? For most of public IoT, there is no physical security for these IoT devices. Even in kind of commercial settings like coffee shops and stuff, a lot of those things aren't even locked down. You can see the IoT devices physically open to public people. And then the network that it goes across. Lots of great stuff, lots of great security technologies in our SIM cards and such today. But ultimately, it's a public network that things are moving over, whether you're on a hotel network, a public cellular network, or other Wi-Fi. Similar challenge on the right-hand side. I call out users specifically. Users sometimes are intentionally or unintentionally malicious. Some of the best things we found security-wise were just kind of hobbyists looking at devices, trying to understand how they work, and then suddenly becoming overly empowered because they found security issues. So whether that trusted user or that untrusted user on the other end is doing what you expect, they are ultimately an actor that we have to figure out how we can establish trust with. And then yet again, there's another network on the other side. So all this comes together, and especially on the left-hand side, when we're talking about IoT, we're really looking for how can we trust that device? How can we be sure that device isn't being spoofed? Has someone else taken a copy of it and is logging in and pretending to be that device? How do we know that data is not being looked at across the wire as it's going along? And then how do we know that maybe the device is the valid device and it's got secure communications, but we don't know that the person using it is tweaking in a way that's causing a misbehavior setting that can then cause insecurities along the way? So we really are kind of looking for those threats and trying to resolve those threats by adding trust to the overall environment. So where do we think and where do we start? And again, what's interesting is this list used to be about 3 long when I would present it years and years ago. It's grown to 5 long now of things where I think we really got to solve these well as core principles. But these are the core things that I think about when I've got a new IoT solution and we're trying to make sure it's secure. Let's go over and really knock these things down. And then we'll deal with some uniquenesses that exist in each solution, whether it's the hardware uniqueness, the use case, the security, the physical security use case. But these are 5 things that we look at to start with for how can we establish trust. The first, I mean, the nice thing is a lot of this is well known to many of us now. The first one is encryption. We go to very few websites anymore. As a matter of fact, our browsers get very upset when we're not at that HTTPS URL, that S being the security. That S has the ability to not only be on our website browsers, but on every transmission. So when your device connects, it can connect with encrypted processes so that the data will be turned into something that people can't read on the wire. There are algorithms that do that encryption. Those algorithms have different level of complexity, which results in different amounts of compute requirements. But ultimately, encryption is key to establishing trust in several of those areas of risk between both the device and our system and those end users. So when we look at this now, we really don't even want to consider solutions that aren't putting this encryption in. I'll take it even further when I get about the internal cloud side. But right now, we're just talking about these external connections. The second thing that's important, and I think has been a little underappreciated by IoT vendors and partners along the way, is the provisioning lifecycle. I think it's been underrepresented primarily because it really does require a partnership between folks like ClearBlade, software providers, and then actual hardware manufacturers, people who are making these devices. Each device has a little bit of a different process, a different use case for how it might come online and join your ecosystem, your application ecosystem. Each device needs to come in, though, in a secure pattern. So I really call out provisioning now when we think about how will a device come online. The person will screw it in, will plug it in, will connect the card. Then what do? They scan a QR code that kind of establishes trust back through. Who gives the trust? Is it the user who's doing the field installation? Is it the fact that it came from the manufacturer with a certain key involved? You really have to understand that provisioning lifecycle, because ultimately you're letting devices in. If you're not putting a secure process in, then you're basically letting malicious actors along the way. So I really like to actually even step back in a lot of solutions that are going to achieve great things and say, what is the process for how we're going to put a new device onto this overall application network? It is a challenge because, like I said, most solutions have different patterns for how they like to install, or users have different how they like to install an application. And most hardware use different protocols and have different ways that they get brought online. A LoRa device coming through an LNS has a very different life cycle than a Modbus device connecting through an edge gateway, so to speak, along there. And each provisioning cycle has to be built both in a common pattern, but in a way that is unique for the overall constraints of that hardware. The third element, authentication. This is another one that's kind of like encryption. We've been doing it for a while now. I will say it has changed a bit over the years. We used to just love ourselves a good ID or key, something like a username and password. We used to love the ability to, once it's connected, we always trust it. We certainly have gotten to a phase now where we ask things to create JWTs that time out. We might have refresh tokens that we have to be refreshed themselves. We use OAuth patterns. We use different ways to be sure that the device is securely presenting a credential, saying who it is, and we can trust who it is. MTLS is another authentication pattern we see being used, especially in IoT. So that's great. It's changing. It's getting better, but it must be done. You must make the device prove who it is along the way. The other thing that's interesting about IoT versus, say, users, right? We're not a Salesforce user logging in, so to speak. Devices can't really do a great job at their two-factor auth. They're not walking around with a mobile phone in their pocket to go and then click the auth application to get a new code. They're not looking at their email and copying it through, or their text messages. So while we've solved some interesting challenges of basically people having their passwords open, lost, or whatever, we have a hard time solving that problem the same way with devices, because there is no TFA in that ecosystem. So we see interesting things, rolling keys, refresh keys, all that kind of stuff being done. But ultimately, fundamentally, every device should have to present itself as an authenticated device, and it belongs here. These sorts of things prevent devices from getting in your system and creating denial of service attacks and other things. The fourth pillar, authorization. This means just because it's a device and it's allowed to talk to you, what is it allowed to do? Where is it allowed to write data? What data can it ask for? This is the internals, right? This is, are you a viewer? Are you an editor? Are you an administrator? Are you a reporter? Whatever this device is, just like users have roles and systems, our devices need those same sorts of protections. Why? Well, if you think about it, every user is going to put a device in their home. If you buy your device, they could technically go in there and find that credential. So now they get to do things with that credential connected to your system. Well, you need to make sure that that credential can't go and give me the list of all users in the system, right? That would be a vulnerability that you need to protect. So even with devices, you have to think about what kind of roles, what sort of authorization are these devices allowed to have. In IoT, we have even a more unique problem. Is it's also around the, often it's a topic model for how we might publish. How do you apply what the broker might spec might not have done of protecting certain topics to certain devices for what they can send and receive data on? The last pillar is maybe something that doesn't necessarily prevent issues with security, but it's just so key to ensuring that you still have trust in the system, and that's the audit. You need to keep a history of everything you've done and everything that's gone on the system and build that audit trail. This is a huge challenge because a huge IoT solution that you're trying to optimize and scale, and then if you want to build an audit trail, you essentially are creating triple, 7 times, 10 times the amount of data just trying to remember what happened that you can go look at historically. But you need this audit trail. And often it doesn't come for free. You really have to build it into what you want going on to be able to capture and recreate. Audit trail is also very nice for recovering from events because you can go back and kind of replay and put things back into a state when you knew they were healthy. So you have to really look at your audit trail for a number of reasons, not just for you to understand what happened, but for you to go and maybe recover with what's happened from future events. And that audit trail is key to that. So these are things we use to establish trust in a system. And ultimately, when you look at it, every one of these in the last 10 years has gotten harder and harder and gotten more complex, more things we can do. We want to do better encryption with lower power devices. So the algorithms and computes are challenging with each other. We want to be able to do a 2-hour token instead of a username and password. The concepts are the same, but we are continually improving how we deliver and do these. And when it's all said and done, this is like running from a bear. In the end, you have to keep going, and ideally, you're running faster than others. Bears like your data, they like these delicious things. So we want to keep improving our solutions, keep updating our solutions to run away from these things, stay ahead of these things, and then ultimately protect our data, our users' data, our device data. So there's where it comes from. Don't poke these bears, stay ahead of them, run faster than others. So if we look at kind of an IoT solution, how do we put these practices, those pillars back into the trust of the system? Here again, you can see we have that basic architecture, a single device on the left, our users on the right. We have our ClearBlade implementation here. Again, this is their principles that go on, whether ClearBlade or not, but these are principles of how you would secure this solution. I like to start at a low level when we kind of put these things back into place. And we talk about being able to put new software over the air, OTA updates to our devices. Again, we remember back to where we had untrusted behaviors, that manufacturer, what was the default software. If that software that was put on by default, and originally whether you did it or someone else, needs to be updated, something's wrong, we have to be able to update it with OTA, over-the-air updates. All of these solutions have such scale, you can't ask people to bring every truck back into the shop. I know we've done that for years with our cars and stuff, but OTA really reduces the friction to ensure things are secure. We do see some fantastic technologies. I've called out one that comes with a lot of hardware today. They have these unique keys etched directly into the chips themselves, so you really can uniquely identify. That helps prevent spoofing and others. But again, that's kind of that hardware side I talked about. There's some uniqueness. And then you also need a provisioning lifecycle. Part of how do I trust this device into this ecosystem? Well, you can actually leverage the trust of the end user. The person who's installing it, someone who's logged in as the installer role, can share their trust and bring that device in. I mean, we see stuff, common patterns already for when you buy your new connected smart home device and you scan it with the QR code. You using that mobile app to accept that particular unique device into your ecosystem. That is the user taking the trust already granted to them and giving it to the device. That is the provisioning lifecycle that we want to recreate. So those are just basic things of how do we begin to build that provisioning lifecycle in and keep that device up to date to keep running from that bear, so to speak. Other things we want to do, encryption. TLS, I believe 1.3 is the latest. There's all sorts of algorithms underneath it now. TLS 1.0 used to exist. We used to use SSL. That was before TLS. We keep moving that protocol. That has to keep being updated. There's things like root certificates that have to go into the device itself to make this work. So there's plenty to do once you make that HTTPS endpoint alive. You have to continue to update both your device side and your middleware, your software, your IoT platform, your IoT enterprise instance to support the more modern algorithms that maintain the security of the internet as a whole. This is what you have to do as an IoT solution provider, is continue to provide that encrypted transport, especially over the untrusted portions of the network. For authentication, we see multiple patterns out there. We see things like MTLS. This is essentially some of the trust patterns we use for TLS. We now use for both the device to say, hey, you can trust me because there's this third-party server out here that says I'm valid. This is my unique ID. Every device, the same way your web server is trusted with HTTPS, now has that same capability to present that third-party trust back to your servers. MTLS is a big one. We also see some interesting things like asymmetric keys. This is very compelling to me because even though it's encrypted, even though you're having to renew over and over, asymmetric keys actually mean your password, so to speak, never gets sent over the wire, never goes over the network. So even though it was encrypted, we still don't trust it. So asymmetric keys allow us to generate a unique key from our password on that device side, and then send that unique key that only lasts for a few hours, 24 hours, 2 hours, and then regenerate. So very cool way to basically continue to do authentication in a new pattern with a way that means essentially your password never goes over the air, over the wire. And then we see some other strategies like cyclic tokens, things that work within certain hours, really trying to make it difficult for someone to authenticate as your device. We see things also protecting us at the security level. That middleware needs to be able to understand connectivity rates at a device level, origin at the device level, behavior, how often is it connecting. You really have to be able to throttle that behavior of individual devices, looking for the profile of your expected systems. I showed you that diagram of all the different types of use cases. I'll take a piece of construction equipment. It connects and behaves and sends data very much like the other piece of connected construction equipment, but it sends data nothing like maybe your smart home TV does. There's a profile almost in every case of how your types of devices will connect. You want to be able to identify that profile and then understand and look for anomalies outside of it. Those anomalies might be software bugs somebody wrote, but those anomalies also might be somebody behaving or having penetrated your network and behaving as that device looking to do malicious things. So throttling, controlling, cutting off, limiting, that's key to building a secure IoT solution. Needs to be thought about out of the gate. And then authorization. In our world, just like users have roles, devices have roles. The ability to get right down and say a device can only listen on these streams. The devices can only call these certain APIs, even if they're coming through a streaming model, pub sub model. Devices can only access this user's record, this data structure. Being able to build that authorization, that role by device is critical. I think it's a little underrepresented by IoT solutions out there. The fact that devices really need that much level of flexibility in their overall authorization process. Again, logs, you're going to build up these with your audit trail. You want to be able to metric them. You want to be able to understand the number of types of events. Nothing is more powerful than understanding your connection rate and seeing that you've got a huge number of connect-disconnect spikes going on. What does that mean? Is that a hurricane perhaps moving through Texas, or is that an issue with an attack vector coming from another country outside that you want to be able to understand and potentially put some throttles and protections from? And the last is the users. Just like where we were doing protections, authentications, we have to do the same thing for APIs from what users are doing. Not every IoT provider attempts to give data to users. Sometimes they just throw it out to another streaming service. But if your solution is going to provide APIs for end users, end applications to get at the data, then you need the same level of role access right down to the row and data structure. That, I guess, to set the stage is what we think about with an IoT architecture. Now, let's think about what's gone on in the world kind of prior to IoT. We've had technologies called SCADA for many, many years. Quite frankly, we've had SCADA systems that let us look at our equipment, and you might call them digital twins from 20 years ago, 30 years ago, maybe 40 years ago at this point, right? So this process of connecting physical devices isn't necessarily something that's new to IoT. We've had certainly, energy generation facilities doing this. We've been monitoring pipelines, we've been monitoring ships. These SCADA systems are doing something, and I'll talk a little bit about the characteristics and challenges of why IoT is compelling here, but we'll talk about how we can put security back into those sort of architectures. The first thing to know is a lot of these legacy or SCADA systems have a limited backhaul process. That's probably because they were put in 20 years ago, and 2G was quite the new thing, right? Cell phones just began, so to speak. So very often they've got old modems in them. They're a legacy network, so to speak. So when we look at these systems, we have to think about how much could we really encrypt across the wire? And if we do have to move amounts of data, we probably have to do a good bit of edge processing before we can even use that backhaul network. We see a lot of those systems today. There's a lot of what I think people tell me is attribute lock, meaning the system is designed to give you these 5 fields, and that's about it. The idea that you're going to plug a camera into the existing SCADA system and also process video, that's just not how the system was designed. It's locked to what its SCADA attributes were designed and built to do. There's many different systems, whether it's an HVAC or it's a MES manufacturing system, the SCADA-like mentality. They are generally locked to what they are designed to do. They're not extensible, so to speak. And a lot of this IoT world in the last 5-10 years, we've been using these JSON objects where you just throw new data in and everybody's happy. We don't see that in these kind of older systems. Another nice thing or another attribute is there were no cool protocols. MQTT, it's not necessarily brand new, but it only became widely used, say, with this IoT wave that we've all experienced. So we see a lot of legacy protocols. Some aren't even on TCP. So you're ultimately trying to get data out of what are just old socket streams that people wrote up with just best ideas. And very often, almost always, those really old ones have no concept of security, no concept of authorization, no concept of authorization, and certainly aren't encrypted. That's a huge challenge as we unlock, say, these SCADA systems, and why so many people in the networking world are really kind of afraid to bring IoT into OT, just because it's how do you add security back into this in those legacy protocols. Very often it's a challenge too. Those security people have put in place firewalls that give them that extra control. But then they give very little ability to work with those, modify those, because they don't it's too hard to look at what the impact might be. So we'll have, basically one port that gets opened and that's it. Those are the rules and you have to work within that. That's incredibly challenging for those trying to innovate, bring IoT bidirectional secure capabilities into these environments. So that hard firewall is difficult. And then ultimately, a lot of these OT environments, they have worked this way for a long time, very successfully, added a lot of productivity, but they don't necessarily want to change how they do it today. They're kind of happy with the way it is. They don't necessarily want to change the behavior, and it's hard to unlock the understanding of what's happening when the people that are involved there kind of like it as is. So that's kind of the environment. If you think about, hey, I'd like to go get this SCADA data, I'd like to make it available in my IoT solution, I want to ship it off into my data fabric, you want to do all these cool things, you're coming into this world where OT has existed, and this is kind of what things are set to be. When we look at that architecture, If you look at what people have been doing over the years, you essentially still have a device in the field rather than having that kind of MQTT connection. Instead, we have a SCADA app. There's probably a database out there. We tend to call those historians, those sorts of things out in the field. And then when somebody maybe 10 years ago said we wanted to get this data not just at the HMI, not just on the machine, but we want to go look at what that data is inside of our IT network, somebody created a little kind of app that they installed, a little Python program or something they installed out in the field that really just sent data into the IT network. It popped a firewall hole into the IT network. And then somebody built an app that lets you see it in Power BI, whatever it is, that enterprise app over there. So this is kind of the architecture that happened. The architecture certainly got data behind the IT firewall. Again, you'll notice there's two very clear networks. People who work on IT side do not have access to the physical OT networks. They can't just log into any device out in the field. So they have really bifurcated their company, so to speak. But this moved data across, very often only in one direction. It was a powerful moment. It gave visibility. It let people get email alerts quickly. But ultimately, it's not taking that next step where we want to begin to do edge processing. We want to change things in the field. We want to begin to really begin to optimize how those machines work. And then get that real-time visibility across all of our network at once. And that's where OT has kind of sat there. You do see some very nice things. Some nice things about this, especially from a security perspective. Both sides of this network is trusted. There's none of that untrusted space of people you have to extra protect against. You'll also see things like there's lock and key. I don't know if you've driven by, but almost every box out in the field, even if it's on a power pole or whatever, has a key on it. They keep you out of it. They do things to protect outside users from getting in there. There's physical protection. They do a great job of putting logs out there because this data doesn't all come back over those small wires. You do have a great audit trail, so to speak, sitting in the field. And then because of the era at which it all happened, there's a great bit of security or obscurity, which we all know there is security in obscurity. If nobody knows how to speak your language, if they have to take lots of time to understand it, then the obscurity actually becomes some value to you. And these legacy systems, these legacy SCADA environments certainly give you that. That said, there's some real challenges. So you can't just say, hey, we're secure, and we can begin doing more. There isn't usually any encryption going on at these places. Usually these networks are often open, so if somebody just plugs in, can get physically to the place and can plug in an Ethernet jack, so to speak, a Cat5 cable, they might get access to the wide network. Usually there's no authentication, or if there is, it's very basic. That's how we hear about root still working in all kinds of devices, and then very often no authorization going along. That code, the application interchange, often written by an intern who was really smart, but did it over a summer. Hey, watch this, watch what I can do. It's a homegrown tool. Nobody quite knows maybe how it works anymore. If they do, they certainly didn't spend a ton of time thinking about how do we production size this for security. Firewall, tough to work with, data one directional. Once the data gets behind the firewall into IT, so to speak, is that data live? How do we make sure we keep it live? How do we groom it and manage it? Is it stale? So a lot of challenges overall with this ecosystem. What do I see people try to do? Well, I see people, hey, we're going to get smart. We're going to do IoT, but we're going to take everything we had on the top side there, and we're just going to keep using it and ship it to our untrusted cellular network to a cloud application. This is common, right? This is kind of a first step of how we can improve our solution. But ultimately, there's a lot of risk that shows up in this sort of environment, specifically at that level of once you open up that interchange application to the public network, even if your data just moves one way, there are other protocols on that box, other ways to get in there, ways to kind of work backwards, basically find a level of security and go horizontal with inside it. And you really do begin to put yourself in a lot of risk by putting this here. I've seen all kinds of interesting things, right? So you might open up an HTTP server, but you also open up SSH, and suddenly people are able to get in the box and into the whole network. You thought your data could only go one direction, but for whatever reason, they can update and go back in. So ultimately, it's a real risk because you don't have some of those fundamental elements of authentication, encryption, authorization, even provisioning devices into that OT network environment. So you have to be very, very careful when you start your journey of maybe leveraging what you've got today, getting your brownfield devices, but then opening it up into your public cloud over untrusted networks can certainly provide or open you to a wide exposure. How do you potentially solve that? An edge is one way that we ultimately see that. ClearBlade has an edge, but the edge as a concept is really about trying to solve what is processing just at that point of the end of OT and getting into the IT network over whatever network and path, right? So we talked about all the ways we try to put trust back into that untrusted environment, and that's where your edge can do that. Your edge really is the only outbound point. The edge protects you from, with the authentication and authorization from data being able to be captured externally. Then the edge also has the ability to put the encryption layer back on. So while the north part of this may be doing its standard unencrypted portion, it may be doing its historian work, whatever that is. Once that data leaves the edge and goes over the public network, it all becomes encrypted using the best practices of IoT. The edge also has the ability to be kind of bi-directional in the controller in a way, so it can bring in the OTA, it can put throttles on behaviors. All of that can be done thanks to bringing the edge into your architecture. This also can be done. Again, I show the public network there. That's where people like to start. Very often they're trying to figure out what is the value. You don't have to live in the public network with this architecture. Obviously, you can bring your edge to platform all running on your private networks and still maintain that infrastructure as is. So you talk about bringing now, we had the untrusted. Now you also can actually have the high trust and your trusted networks all still running the same architecture. A great way to ensure. There's interesting things about this. You actually can take this into the Purdue model. Not going to climb into that. Different layers, layer 3, layer 6, even when you're trying to get it inside and outside of the IT OT network. But ultimately, you can build designs that ultimately still comply with what is the Purdue compliant. Maybe multiple edges are required, but you can sit overall in that strategy. So I really look to this when I think about it, and I see what is generally an ideal best practice for those trying to build a mature process for creating an IoT environment out of a legacy OT SCADA-like solution, and then securely binding it into their standard enterprise network processes. This is a bear having fun, not trapped in a bucket, but having fun in the bucket. But also, our bear is not the big risk to us now with a bucket on its face. That's for sure. Last thing I want to mention and bring up was, I talked a lot about kind of the device side. You can still see that on the north part of this, the top part of this diagram, the edge, capturing that data, bringing it through bidirectionally. There's still a cloud network that potentially is where you're going to run your IoT solution. We're going to take some of those IT practices we saw. There's still be firewall rules. But once you're behind that firewall, there's still a whole level of maybe pieces and parts that are moving around behind the scenes. I alluded to it before with the three, the application, the broker, and the database. Well, those pieces are still sitting there. If you're using a cloud, you're probably going to use some cloud services. You can see those referenced on the right. You may be using some data persistence on the left. You've got your monitoring and audit log tools. All of that's sitting there, and you really have to think about even those interactions. Yet again, it's important to do authentication. Each application should authenticate to the database. You need to be sure you're protecting those credentials. When you look at it again, you need to be sure that you're encrypting traffic throughout that network. There's really a bunch of things that are done thanks to some of the cloud services that are out there. And I try to call out a few of those, whether it's the DDoS protection, whether it's helping provide automatic encryption as data moves across the traffic between the systems, storing your secrets in a secure way. ultimately providing private and public networks for you to control. Off services like the two-factor off. We see a number of services trying to do or providing IoT anomaly detection. And even in some of these systems, Kubernetes provides an additional layer of security, protecting your raw compute from your containers themselves with their own networks. So really, I don't want to dig too deep into that. This was more about IoT, but even your internal system, there's a lot to make sure how it internally communicates, that you don't open it back up and give too much power into that public network set of behaviors. So that was a quick background. Hopefully I said some things that you've experienced. Hopefully I've said some things that's another point we need to remember as we dive into this. These are things that we work very hard to make work and standard and part of the solution as it comes out of the box. That's ultimately how we look at security. This PowerPoint or this presentation will be more slides in 5 years. We know we're not done. We know OTA is fundamental to doing these next implementations. We know constant updates to our software is important to make sure that we are continually providing the best protection we can in a world where we're being chased by bears, security bears. This happens for us. We certainly are doing this across a number of different industries. Kevin and I talked a bit about digital twins to kick it off. We're doing this. You can see a couple examples here, whether it's essentially providing generative AI for how you might describe your system and quickly, rapidly defining all your elements, having digital twins, connected digital twins so that IoT data comes in immediately, making predictions, taking actions, building up your event tree, building up your audit history. We do this for facilities, energy, transportation, water utilities. A number of different customers and partners of ours are doing this today. We think it's fascinating to see these things, how quickly they come online. We have the ability to understand what their state is. We're preventing truck rolls. We're having a lot of productivity saved, cost saved in these solutions by just providing what is a IoT infrastructure, a secure IoT infrastructure on top of what might be traditional SCADA-like environments. For water as well, predicting leaks in networks, tons of different things you can do as you merge these data sets together to not have to go and put sensors on everything, but to simply understand what data we've got, meters we've got, make predictions, and begin to find leaks with a 50% hit rate out of the box. We also do it interestingly with things like solar, understanding how we'll do maintenance. How do we know that what's wrong without having to go out in the field? So when we do show up, we have the right part. How do we predict that, say, a solar panel is creating the right amount of power at the right time of day compared to what is the weather right now? All of this is being done with our digital twin application, intelligent assets, again, on top of this secure architecture. With that, again, I hope I see you all in Harrisburg at the IoT Live Slam. I will be in August. I'll be out in Sunnyvale if you're interested in talking security yet again. I'll be doing that in Sunnyvale, so please check our event page for that. And with that, Kevin, I'll kind of open it back up to you if you can join me and help me with any questions that might have come up during the conversation.